the cloud. Okay. All right, let's do this. All right. Does anyone have a specific thing or topic they want to go over in particular? If my voice sounds muffled, it's also because I'm eating lunch right now, so that's why. But topics, I'm taking suggestions. Printing shapes, command line arguments. Okay. Is printing shapes under which one? Okay, shapes. Okay. Do you have any questions in particular? Let's see here. What's this? Okay. Where are the shapes located? Nested loops. Oh God, okay. Um, exam 2, final practice problems. That's from exam 1, right? Nested loops. Okay. Hold up. So we got nested loops. Well, okay, right here. Complete design. Okay. Let's start off with a few nested loop questions, and then we can move on. Number 78. All right. Files. Are you talking about command line arguments? Let's do this. Okay, so let's start off with this one. Okay. Write a complete C++ program that does the following. Carry out some of the tasks for partial credit. It asks the user to enter a positive integer value x. The program reads the value entered by the user. Okay. IO files. Does he have practice questions for that? I don't know if he does. If you have any questions in particular, feel free to sound like a file that has a question. I'll be honest, I don't really know anything about IO files in C++, but let's see. So let's do this question. If I make a mistake, please feel free to shout out, or if anyone's confused, once again, feel free to shout out. All right. So it asks the user to enter a positive integer value x. The program reads the value entered by the user. If the value is not positive, the program repeatedly makes the user type in another value until a positive value of x has been entered. No positive means greater than 0. The program prints a triangular pattern that is x rows high. The characters 0 and 1 are used to print the pattern. Odd numbered rows are printed. Oh, 74. Okay. Yeah, that one wasn't pretty bad. If you guys want, I can still do this one afterwards, but let's do 74. Whoa, oh dear God. Flip is this? What is that? Hold on. What is that? Cube 74? Okay, I don't want to do. This is very, I don't think you're gonna get this on the exam. I don't think, yeah, you're not gonna get that type of question on the exam. It doesn't really make sense to do. Right? You're probably gonna get something looking like this, like this. Maybe something like this is like not too bad, but maybe this. Okay, let's do this one. 78. You can get something like 78, 77. Because he did one over in the first exam, I don't think he's gonna give that much something too difficult in the second exam. Not the second exam, the final, regarding 2D shapes. Regarding these shapes, so let's do that. Okay. So this one is basically asking um to ask a user for a value, if you enter the wrong value, keep asking. So let's do this. It's pretty self-explanatory. Okay. The regular beginning using namespace standard. int main. Okay. Now let's do this. So we want to store an x. Let's have like say n, right? The user value. And now we want to do, first we want to enter, sorry. We want to tell the user to enter something. So let's do that. This is question 78 of nested loops. So you'll find this under first exam material. Okay, question 78. So C out, I don't know, enter in a positive integer, right? And then we C in n. Okay. And now that's the first part, right? That's check first part. Second part then says, the program reads a value entered by the user. If the value is not positive, the program repeatedly makes the user type in another value until a positive value has been entered. Okay. And he says positive means greater than 0. So while, what should be in between these parentheses? What do you guys think should be in the parentheses? If we're checking, if we want to ask again if they didn't enter a positive at the end of the cout. Thank you. Feel free to like correct my mistakes, but what do you guys think should be in the while statement inside the parentheses? And you're close. Remember, there's a reason why your professor adds this note. Positive means greater than 0. What is the opposite of, yeah, there you go. That is the correct answer. Right? And while that's true, we want to keep asking. So we do cout long input, enter a positive integer, right? And cn. Okay, that's good. So now we have the integer, we made sure it's correct, right? Now we need to do the for loop. So let's do the first of the basic outline. For int r is equal to 0, r is less than what, let's leave that blank for now. Blank, r plus plus. Right, and we got for int c is equal to 0, c is less than blank, b plus plus. Okay, r is less than or equals to n. Okay, we could do either, okay, 4 rows, yep. Well, okay, we'll get to that in a bit. If we start from 0, should we go, I see what you're saying, less than or equal to, but should we go less than or equal to n or strictly less than n? Because that makes a difference. Yep, just less. Because we're starting from 0. 0, 1, 2, 3. 0, 1, 2, 3. Okay. So that's important because it starts differently. If you started from 1, then it would be less than or equal to n. Right? That would change the code. Sorry, guys. I'm just chewing. But R is row. Oh, someone's in chat. Muted. You've been muted. R is row, right? And we are fixing the row and moving the cursor in the column. Yep. R is row. C is column. That's usually how they do it with 2D arrays and shapes. So I'll stick with the basics. So now let's do this portion right here. What should C be less than? Or less than or equal to, for that matter? Look at the example given. What do you guys think that C should be less than? Let's look at the first row. All right. Remember, we're starting from 0 in this case. So what do you guys think C should be less than or equal to? So in this case, these are the values of R. C goes here. So C is 0, 1, 2, 3. Any ideas? I'll let you guys think about it while I take another bite. C greater than R. n. I'm sorry. If C is greater than R, as I do, I'm sorry if I butcher your name, but let's say here. R is 0. So in the first iteration, R is 0. And here we start from C equals 0. Okay, that's going somewhere. C is 0. Is 0 greater than 0? Yeah. That's that. Yeah. If this is the case, then it'll never run because C is almost never going to be greater than R because they both start from 0, 0. And for Rachel, you said less than or equal to n. Well, then, if that's the case, then it would have printed like a rectangle here, right? See how there's blanks, right? If it's C is less than or equal to n or less than n, then it would have printed like something 1, 1, 1, 1, 0, 0, 0, 0, 1, like etc. Right? We have to, like Jane said, we have to base it off of R. So in this case, it would be C less than or equal to R. Okay? Because we're basing it off of R. So here in an example given, this is why you always like look at the example and like try and like reason through it. And when R is 0, we only print it at C is 0, right? When R is 1, we print it when C is 0 and 1. When R is 2, we print it at 0, 1, 2. Okay? So that's why we have it less than or equal to R. Right? Does that make sense for everyone here? Any questions? You didn't get it. Okay.
I have a question.
What's popping?
So I sort of get it right now. So if the row is 2, that means it will print out 0, 1, 2, 3, 1 in total. Is that what you mean? And then for row 3, 0, 1, 2, 3.
Mm-hmm.
That what it means?
Yep. Always look at the indices. Like this is why whenever you have these drawings, it helps to like draw out. Let me draw it here. Like label everything. Let me show you again. The rows go in order 0, 1, 2, 3, right? Because we start from 0. And if you label the columns are also 0, 1, 2, 3. I think Zaidul, you also had a question. You didn't get it. Okay, this is me re-explaining it. For R, it's obvious that we want R less than n because the user enters 4 and we print out 3 rows because we start from 0. Okay? Is everyone okay with that? Why R is less than this portion? Everyone okay with the outer loop? Okay? Okay. So now the inner loop is different because we only print it out. See how like we don't go the entire row for every single so for each row we don't go the entire way, right? Like for row 0, we only print one number. For row 1, we print 2 numbers. For row 2, we print 3 numbers, right? So that means that the number of columns per row isn't necessarily based on n or the input. Rather, it's based on the current row that we're on, right? So that's why we always, for inside the nested loop, in this situation, the column only prints out, and this is another reason why labels help. See how in row 0, we only print for column 0? For row 1, we only print for column 0 and column 1, right? And we keep going. So say we had well, I'm not going to add another row, but for row 3, we print for columns 0, 1, 2, 3. And this is another reason why I said in the very beginning, when you choose like the indices, that'll change like your answer because it changes like what the numbering is, right? So here we chose 0, and when by choosing 0, it gives us one answer. If we were to choose like if we started counting from 1, then it would have given, well, not here, but like you'll see in the if statements, but it changes the answer a bit. Okay, does everyone understand the inner for loop now? Just it's based off R. That's why we say less than or equal to R. Okay, is everyone okay with that? If you guys aren't okay with that, just feel free. I'll go over it one more time if everyone's okay with it. If some people are confused. Everyone okay? Anyone? Anything? Life, vitals, anything? All good? All good? Okay, got it. Fixed rows and it progresses, the number increases as well, but for column it prints a fixed number within a given row in that column. If I'm understanding what you're saying, Zaidul, if we were to say like it's less than say n, then that fixes the number of columns per row. But by changing it to just to less than or equal to r, that's what gives us the ability to how each row doesn't have the same number of columns. That's what gives us like the what I think you mentioned, it progresses. Yeah, I think I understand what you said, but yeah, this is why it's based off R, not N. Okay, got it. Everyone good with it? I think Rachel, you said you had a question about this as well. Everyone good with it? Okay. So if everyone's good with it, now let's do. We're almost there. We're almost at. Actually, one second. Let me just before anything. It's at the very end. It's just don't forget to add return 0. It's like for a rule of thumb, right off the bat, like don't forget like these simple things like int main, include IOStream, return 0. Like say you don't get the question at all, even if you include that's like a point. So it's like very stupid to lose a point because you forget return 0, in my opinion. So that's a piece of advice. Okay, so now we have to look at the rows and the numbers printed. So look, when R is 0, we print 1. Okay. When R is 1, we print zeros. When R is 2, we print 1s. When R is 3, we print zeros. Does anyone see a pattern here? While I take another bite of my lunch. What's the pattern, Rachel? When odd, 0, okay. And then when you print 1. There you go. All right. So let's code that. So if, what do I print in the, what do I put in the if statement, guys? What you going in? How do I check if the row is odd? Okay, that's for even. We do that too. Mm-hmm. Okay. So if the row is even, what do we print? We print out ones, right? There you go. Okay, so if the row is even, I think Rachel is saying you meant 0, right? We're starting with even. If we started with odd, then we would do else C out 1. But since we're starting with even, first we do if R is 0, we C out a 1. If R is an even row, we C out 1. Else, like we don't even need another one. So else, we don't need else. Else C out 0. Right? Because a row number, any number is either even or odd. It's not like there's another possibility. So once we know it's not even, we already know it's odd. Okay? That's why we could do it. And if you want, you do it another way. So like if it's like the other way, if it's 1, C out 0, else C out 1. Either way works. Okay. And yeah, that's the code for this question. Is everyone okay with it? Everyone good? Anyone got any questions? You're right. I'm sorry. You're so right. After this curly bracket, C out and line. Good catch. Very good. Did anyone see any mistakes You figure it out if there's any mistakes. I think it looks good. Does anyone have any questions about this? We'll do a few more shape questions before moving on to, I think, file, command line stuff. You guys are good with that. Anyway, everyone good with this one? All right, let's move on. Okay. We're not gonna do something like this. Is a monstrosity. You want to do this one? Prince a T. Sure. So we're printing a T. Alrighty. So ask the user to enter an odd positive integer. Reach the value. If the value is not correct, repeatedly makes the user type in another one. Yada yada yada. Okay. So let's start this. And also, bit of a disclaimer, these questions can be done in multiple ways. It's not obvious. Just because I do it a certain way during the review, or someone you see does it in a certain way, doesn't mean that's the only correct way to do it. Okay, so like even it's like you say you do something and it doesn't look like on the exam you write it out and it doesn't look exactly like how I would have write it out or someone else would write it out would have wrote it out. Don't feel discouraged. Always think about like how you would write it and how you're comfortable writing it. Right, different people are comfortable doing different things. Just want to like make that clear. All right, so let's do the usual. Int n. See out, enter an odd positive integer. Okay, cn n. While we want to ask again. I'm just gonna fill in the blanks. What do you guys think should go in the parentheses for the while loop? You guys can say it in the chat if you want. I'm just writing out the rest of the code. This is pretty self-explanatory. If I lower the size, are you guys able to still see the code? I'm running low on space. Okay, n mod 2 not equal to 1. Okay, that's 1. Well, n mod 2 is not equal to 1. That's 1. That's 1 condition. What's the other condition? There's another condition. Any ideas? Read the question carefully. Yeah, n less than 0. There you go. Or right here. This is idle. I think for what you wrote in the chat, it looks correct, but just to be sure, once again, this is like style, but I personally like having parentheses around like individual statements because I don't want to like, first of all, like if someone reads this, they can like think that that not is applying to both statements, right? Which you don't, which it's not. It's not applying to both statements, but just to be safe, like this is what I would do. But once again, it's personal preference, but up to you guys. Integer cn n. All right. So that's part 1 of the code. I'm gonna do part 2 on the right, so it doesn't overlap over text and it's not visible anymore. All right, let's do this. Once again, simple things. Turn 0. All right. So now let's add the for loop. So once again, we would do for int I is equal to 0, not r, let's do r is equal to 0. R is less than, what would r be less than or equal to? Any ideas? Less than n, yep. Less than n, r plus plus. Okay. And now we have for int c is equal to 0. What should c be less than or equal to? Or less than? Any ideas? Okay, if we set it less than r, then let's look at the example given. So rows 0, 1, 2, 3, 4, 5, 6. If we set it less than r, let's do the column as well, 0, dot 6. Okay. Set it less than r. Then here, this would only print if it's less than or equal to r. If it's less than or equal to r, then it would only print this star, right? Because then after this star, c would equal 1, and 1's no longer less than or equal to r. Okay. So if we use less than or equal to r, we're missing out on this entire row right here. And quite frankly, we're missing out on this, this, and I think we'll get these last, but we're missing out on a bunch of the stars. So less than or equal to r or less than r doesn't work in this case. So any ideas what would work? Not greater than, because remember, if it's greater than, then c is 0. Once c is 0, c is 0 greater than 0? No, so it wouldn't work. It wouldn't print anything. C less than n, bingo. Right, and the part that gives you the answer is this very first row, and that C prints out everything in that row. So C technically goes up until n, right? Is anyone confused with that? Everyone okay? Also, for anyone who came late, yeah, the attendance form, I forgot to put that. Please fill up the attendance. Today we have a really small group today, but is everyone okay with why it's less than n? No, I lost someone. I put the attendance form, someone gone. What the hell? Anywho, is everyone okay why it's less than n? The real gimme that why it's less than n is this first row. Anyone have any questions about it? Anyone at all? Anyone at
I have
all?
a question.
What is up?
For the while loop,
Mm-hmm.
can I also use,
Mm-hmm.
because it's the user entered them, and so for me, I like to start at 1. So if I start at 1, I would say if n mod 2 equals 0, then invalid input, that's okay also, right?
Say that one more time.
If I start at 1 for the for loop, then for the while loop,
Mm-hmm.
then I'll just use n mod 2 while n mod 2 equals 0, see out invalid input. That's also fine, right?
So you start at 1. Well, for the while loop, if you put while n mod 2 equals 0, that I think is good. But I think like the while loop and the for loop aren't really related, other than the fact that the while loop just gets the integer. And the input. It's like regardless of whether you start your for loop at 1 or 0, the while loop basically has to check is it if the user is entering an even number or whether the user's entering a negative number, then you got to keep asking for a user input. Does that make sense?
Yeah.
Okay. Was everyone good with why it's less than n? If not, please say so. Otherwise, I'm going to take the silence as you're all good. Okay. So now we have to print out the stars. And this one's a bit weird because the first row prints every star, right? So what does that tell us? At what row number does it print out every single star in the column? R is 0. Okay. So if R equals 0, then what do? We see out a star. Also, let me just put the line here. Don't forget. Okay. Otherwise, if the row isn't equal to 0, then where do we print out the star? Else. N plus 1 divided by 2, I think. Yeah, I think it's n plus 1 divided by 2. Josh, it's not. The reason why it's not n divided by 2 is because, wait, never mind. Wait, hold on. Because we start at 0, 0, 1, 2, 3. Yeah, I think it's n divided by 2. Rachel, if you were to do n plus 1 divided by 2, then it would. Because if you were to start at 1, right? Say you started the index at 1, then it would have printed it at 4, right? And in that case, if we started from 1, from C equals 1, right? Then we have to print it out at the 4th column. That's why we do n plus 1 divided by 4. So in this case, because if we started from 0, right? We want it at column 3. So that's why we do 7 divided by 2 is 3.5. But because it's integer division, we get rid of the double, not double, the decimal. Whereas if we were to start at 1, we want that row 4. So how do we get 7 to 4? Well, we add 1 to 7 plus 1 divided by 2 gives us 4, right? So for Rachel, in your case, if you were to start from 1, if you start your indices from 1, which is also perfectly fine, in that case, you could do n plus 1 over 2. But in this case, the way Josh said it, n over 2, that's perfectly fine. Okay. So we would do. Is everyone okay with what I just said? Do you understand why it's now n plus 1? Well, no, like why it could be n plus 1? Once again, it depends on the indices. That's why the indices. All right. So if we were to start the indices, so in this question, right, we started the indices for the row and the column at 0. Okay. Why does this impact the answer? Because, well, if you look at the column index specifically, we want to print it at the very middle, like at the middle column index, right? Right here. Well, if you start the counting from 0, this is 0, 1, 2, 3, right? So, yeah, that's why. If you start from 1, which is also perfectly fine, then you could, then your way works. But in this case, we start from 0, 0, 1, 2, 3. We need to put a star at column 3. How do we get 3? We do the input, which in this case is 7, divided by 2. And because it's integer division, dividing an integer by an integer gives us an integer. So even though 7 divided by 2 is 3.5, it gets rid of the 0.5 and we're left with just 3. Okay? Otherwise, if you were to start from 1, right? Start from 1, 1, 2, 3, 4. This is now column 4, right? Everyone good with this? Yeah, I think everyone gets it. But just to be sure, this is now column 4. So now how do I get 4 from n is 7? Well, if you do 7 divided by 2, you'll get 3. So let's just add 1 to 7, right? So 7 plus 1 is 8. 8 divided by 2 gives us 4. Okay. I think everyone's got it. So, but yeah, that's why it depends. Once again, the answers could be different. It all depends on your own preference. But depending on what you say, like what you set it as, it then impacts the answer. And this is like a key example of it. If we started from 0, it's else we check if C is n over 2. If you started from 1, you would check n plus 1 over 2. Okay? So it's going to be else if C is equal to n divided by 2, then we print out a star. Okay? And then that's it. That's the code. Is everyone okay with this? Yeah, on the exam, I expect, can you write 4C is equal to n over 2? Yeah, that also works. That also works, yeah. What Josh is saying is, once again, like, this is another example. You could write it. There's different ways of writing the same answer. This is one way of writing it. You could also write it instead like this. If r is equal to 0 or C is equal to n over 2, boom, that also works. Oh, yeah, sorry. Else C out space. Thank you. But yeah, there's two ways. There's another way you could do it, right? You could add the or if you want to add an else if. In this case for this class, it doesn't really matter. N divided by 2. Right? It's perfectly fine. C out star. Right? Once again, there's multiple ways of doing the same question. Okay. Otherwise, you got to see out of space. So otherwise, if it's not, you see out the spaces. Okay. Is everyone good with this question? Any questions? Did I make a mistake? Please point out any mistakes. Everyone good? Yep. Okie dokie. So now the question becomes this. Do you all want to do another shape question, or is there another topic that anyone here is interested in? I'm opening the floor to peeps. All right, recursion. Okay, so while Idle, you find the 2D array question, let's do some recursion. Okay, does anyone have a question? Does anyone have a question in particular they want to do from the recursion sheet? Recursion is fun. Recursion is very useful. It may seem annoying now, but trust me, when you end up taking, if anyone here ends up taking like data structures or like end up taking future algorithm classes, recursion is big. It's huge. Does anyone want a specific question? Program design is number 88. Okay, so we'll do program design number 88 after a few recursion questions. 88. Okay, let's put it here. Okay. Does anyone have a recursion question? Which recursion question do you think will be on the exam? Oh, great question. I think it's probably gonna have to either be my odd is it's gonna be something to do with like integers or something to do with numbers, in my opinion. It's like something like rotating the digits or digit match or stuff like anything to do with like numbers, I feel is fair game. Like you're not gonna get I think there was a question, I think someone brought it to me a few tutoring sessions ago. There was one with rotate digits. Oh, okay. But it's gonna be like something number related, I think. Char manipulation. Okay, we'll do that as well. If rotating addition is not gonna be on it, we could skip that. Do you want to do digit match? What, rotate digits? I mean, this one's pretty straightforward. It just moves to, actually. Rotation is not that bad. It's not that bad. It isn't. We'll skip it though. We'll skip it. Does anyone want to have anyone have anything in specific they want to go over? Hmm. 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 Okay. Is your reference to diagram of the horizontal bars? Top. Not doing that. 1 plus 5 plus choose. Okay. Anyone have anything in particular? Positive. Calculates an answer by turning the first 7 gated parameter. Here's a copy of the parameter. Cursive algorithm. Interlace digits. I think I went over this one before. You want to do this one? Interlace digits? Interlace digits. Whoa, another student. Got a late shower. Anyone have anything particular they want to go over? I don't really know what's going on the exam. I'm trying to. It's not gonna be rotation apparently. So maybe I'm thinking it's gonna be something like number related, which is yeah. He's not gonna give anything other than numbers, like something. This. Um. Hmm. Digit difference. 0 to recursive function. Okay, okay. 18. This one, digit difference that uses two positive integers parameters. Okay, sure. Let's do 18. Oh no. There it is. Okay, digit difference that uses two positive integer vector parameters with the same number of digits and returns an integer whose digit is in each position is the positive difference between the two digits in that position in the input parameters. If a negative parameter is given, or if parameters with unequal numbers of digits are given, your function can return any result of your choosing. For example, a program that uses the function digit difference follows. Okay, let's do this. So we got a function. No, I lost it. No. I lost it. So we got a function. Let's call it. So what does the function return? Let's start with that. Oop, got a chat. Can I do 134 afterwards? Sure, I'll do 134 afterwards. What should this function return? Returns an int. Beautiful, beautiful. What's function name again? Digit difference. Okay. Digit difference. You didn't get the question? No worries. We got a few recursion questions, so that should be enough practice. Okay, and what is a parameter? What is the parameter of this? What are the parameters? String function, short answer question. Sure. We'll do x int y. So after this one, I'll do, I think someone said 134 for this, and then we'll do 88 of program design, then we'll do characters, string functions, and short answer questions. Okay. Int x, int y. Okay, so let's do this. So we have to print the difference between the digits in them. So the idea of recursion, right, is you have a task to be done. You're paid the big bucks to do it, but you don't want to do it. None of us do. That's why we're computer scientists. So what do? You give a smaller portion of it to the computer to do. To the computer, little beep boop right here. Sec. Little screen, API, little keyboard. Beautiful drawing. You give it to the computer, and the computer returns the correct. This is a key portion. You trust that the computer returns a correct response to it. And all you do is just latch on the portion that you missed, that you took off initially. You put it back onto the solution given, and there you go. And that's the difference. Okay? So, first of all, we have to have a base case. Okay, what's going to be our base case in this case? Anyone? What do you want the base case to be? What's like the simplest case? Or even like, also for anyone who's late. Less than 0, less than, well, less than 10 is also a good shout. I wouldn't do less than 10 though. Yeah, I'll tell you why. Because if it's less than 0, the good thing about having like if less than 0, I'll show you why. If like say x is less than 0 or y is less than 0. I'm sorry, this is a 10, not 0. Right? What this will help is eventually, right? The idea of recursion is because we're going to make the inputs smaller and smaller and smaller, right? Okay, less than or equal to 0. Yep. Then, or actually, let's do less, just strictly less than, because there could be a possibility that the digit, like you have like two inputs being like 11 and 90, right? That's a possibility. So a 0 could be a digit, but if it's strictly less than 0, that means either they're both, one of them is negative, or their sizes aren't equal. Why? Because you'll see eventually that we just keep chopping them down and down and down. Once we hit one being 0, or actually let's do that less than equal to 0 in that case. Because once one is 0 and another one isn't, that means they're unequal. So if they're less than or equal to 0, or y is less than or equal to 0, return 0. Okay? That's the base case. Put this all in one line, save space. Is everyone okay with the base case? Any questions about the base case?
Sorry, so in most circumstances, when you're doing a recursion function, right? Most of the time, I want to say most of the time, right? But most of the time, you start off with putting ints and then the name of the function, and then you put int x, whatever. And then after that, most of the time, it's always if x is less than 0, right? And then you put return 0. Because I kind of noticed how like most of the time with recursive functions, that's usually like how it starts off with x is less than 0.
Bingo. That's basically it. Because the reason why that's the case, well, this first line right here, this is just like the function title line, right? Every function needs that. But you need this line because this is the base case. The idea of recursion is that, okay, I don't want to like confuse everyone because like this is something you learn like later on in CS, especially like in data structures, the idea of like creating a recursive tree, etc. But the basic idea is what we're doing right here, like right here, technically the computer does the same thing, right? It's kind of like if you have a task, you don't want to do all of it, so you give part of it to someone else, and they do the same thing, they give part of it to someone else, and part of it to someone else, right? And they keep going and going and going. There has to be a part where it just stops, right? Otherwise, you're just going to be infinitely giving people work, and you're never going to get anything back because what you gave, never is never being stopped given, right? So there has to be a case where it's like, nope, I can't give it to anyone else. If it does, it just makes it look like I'm lazy, etc. Then they have to give it back, and that's when the cycle eventually comes back to you as a user. So in recursion, especially, this base case, in my opinion, is like the most important line in the entire function code. Because without it, not only would like your entire question be wrong, well, not entirely, but like the question will be wrong. Like if you code it without a base case, you will see like your computer just crashes because it just keeps going and going and going. It'd be like those errors where like infinite loops, it just keeps going and going and going and going. It'll never know when to stop. So that's why you'll see, like you mentioned in most cases of recursion, they'll have this first line like if x less than 0 or something, return 0, just so that the computer knows, oh, when to stop. Right? Does that make sense? Because that's the whole idea of recursion. Like, and once again, I don't want to confuse everyone here because this is like a topic that you learn in later on, like the higher level courses, like the idea of a recursion tree. You have a task, you break it down, smaller task, it's broken down, smaller tasks, etc. Right? And then that recursion tree shows just how, like the idea, like right now you're just hearing, give the computer, like I told you, a smaller task and trust that it returns a correct one. Well, that trust is coming from this recursion tree. Like you'll see it break down the entire problem. And this base case is the like one line that prevents like a total meltdown of the computer. Okay? Is everyone good with that? That's like very important. Because like you'll see, I mentioned it, it does seem annoying now, recursion. Like I remember I was in your shoes. I was like, why not just use a loop? Just use loops all the time. But you'll see later on that recursion is a very, very, very useful tool in like in solving very like difficult questions relatively easily. Right? Is everyone okay with this? Everyone good? That was a speech, a spiel I had.
Thank you. I also have another question.
What's
So,
up?
in what circumstances would it not be equal to 0 then?
What do you mean?
Like, let's say, like, are there any like recursion, I guess, questions where instead of putting x is less than 0, it would be like x is greater than 0, or is it most of the time always just gonna be x is less than 0?
In terms of numbers, it's almost always exclusively going to be like less than 0 because or like less than 10. Like say the smallest case of a number is like one digit, right? Then the whole idea of recursion is that you want the smallest case. And it wouldn't really make sense if like x is greater than, because then that will almost entirely be true. You want it so that the if statement in here to be like the smallest, like the simplest case that you can't even simplify any further. So that's why usually it's like x less than 0 or like x less than 10, showing that like if it's a one digit number, stuff like that. Okay,
Okay, thank you. That makes so much sense. I appreciate it.
no problemo. All right, so that's the base case. Simplest case, if either or the numbers are less than or equal to 0, just return 0. Okay. Now, once again, we must do the trusting of the computer. Right? So what I'm going to do is I'm going to say int a. And once again, these questions can be done any way that you want. This is how I like doing it. I like storing things in separate variables, like having things organized. You may do it separately or differently. That's personal taste. But what I want to do is this is the part I'm going to give the computer. I'm going to tell the computer to compute digit difference of a smaller input. So I want to turn whatever input I initially have, I say this, I want to give it a smaller input to the computer. How would I make these numbers smaller? Anyone? Divide by 10. Yep. So you do int a is different digit difference of x divided by 10 and y divided by 10. Okay. Oh, shoot. I have to. No, don't leave. Whoever just left me back. I need to give you feedback form. For anyone who doesn't need to leave early, I think there's going to be another 111 review session for another class. I think Chin's 111. So if you want, feel free to stay for that one as well. You might need to leave and rejoin, but I'm just letting you guys know. But if you do need to leave early, that's the feedback form. I really do appreciate any feedback given. Like it could be as like if you have feedback, don't hold back. Don't hold back. That's all I'm saying. All right, I need to know like how I could improve these sessions. We're gonna have like more of these next semester for the different classes, so it would help. The feedback would help. So, anyways, so int a digit difference is whoa. We're entering now. It's like 2:15. Int A is going to be this portion right here. This is A, given right here. The computer, I give it to the computer. Happy little guy gives back the correct answer. I now have it stored in A. Sorry, what was that? Oops, sorry. Never mind. So for example, if I were to use this as an example, right? The computer will give me, I give the computer 99, 111. The computer gives me 88. Okay? So the computer gives me this portion. Now all I need to do is solve for this portion. How do I do that? Well, I use the parts that I took out initially. Bada bing, bada boom. Okay. Alrighty. Is everyone okay with so far about this portion? This is a recursive step of thing. Let me just like give a little layout of recursive functions. Recursive function layouts. So you got function, what was it? Return type, function name. You got parameters. Most of the cases it's going to be base case, recursive step, and then next steps are just putting it all together. Which could take more than one line, take multiple lines, but like this. So this is like a basic recursive layout in my opinion. What the hell? In my opinion. There you go. Okay, go back to this. So is everyone okay with this portion? We're just trusting that we give the computer a smaller task to do. It'll return the entire thing correctly. Okay? Everyone good? Everyone good? Everyone okay with that? I'll give you a minute to respond. All right, check my notifications. Is that necessary? What is necessary? A minute to respond? I feel it is very necessary. Oh, simplifying it for the computer? What do you mean by simplifying it? We're not simplifying it. We're giving the computer a... Wait, are you talking about like this? Like the int a equal this? Once again, this is all preference. I like doing it, having things like separated. Like you could technically you could do this all in like 1 or 2 lines if you so wanted to, if you're like a goated Google-esque software engineer. Which by all means, if you are, I ain't judging you. But I like personally to have it separated so that I know each, don't be writing profile, what each part does, and like then it makes it a bit easier to read, in my opinion. It's better, it's like nicer code. You could write it all in 1 line and it'll be like super fast and you're like, whoa, genius programmer. But especially if you have like someone's grading your exam and it doesn't help if your handwriting is bad. If you write it all in 1 line with bad handwriting, it's not gonna bode well for your score. But yeah, it's not necessary to like write everything out in steps, simplifying it for the computer. But it's personal preference, right? And sometimes like you should keep in mind how many lines you're writing, because sometimes we'll give like right here, your function should not use more than 5 lines of code, right? Like he'll explicitly write out what he expects it to take, but yeah. Anywho, let's move on. So now we have this portion. We need to add the 8. How do we do that? Well, now let's have the numbers. So we have x and y. So let's say int b is equal to x mod 10. And once again, you could do this in however way you'd like. I like having them separated. People might not. And c is equal to y mod 10, right? So now we have the last digits of both numbers, 9 and 1. Okay. So now let's have this. So now we have the difference so far. we just need to add on the difference between the last two digits of both numbers. So 9 minus 1. But it could be the case that it's negative. So, which in that case, we have to do an if statement. So if b minus c is less than 0, we add it in a certain way. Else we add it a different way. Okay, so say if is subtracting. No, what do you mean by subtracting? Yeah, we're subtracting the digits. So we're subtracting in this case, it's gonna be the last digit of x is 9 and the last digit of y is 1. Okay? So we're subtracting 1 from 9. So b minus 1. Okay? That's why we're doing it b. But the thing is, it could be the case that say this is 1, this is 991, and then 119. In that case, 1 minus 9 is negative. But we want to add a positive 8 at the end of it. Right? So that's why we have to check. If it's less than 0, which means it's negative, then we flip it, so we multiply it. If b minus c less than 0, return c minus b. Well, no, we want to include that in the digit difference. Right? So let me re-explain it. So say example, we use 999 and 111. We trust that if we give the computer smaller tasks, 99 and 11, it'll return 88. But now we have to take care of this 9 and this 1. So we perform the subtraction. 9 minus 1 is 8. Right? And we pad it on to the end of this, which will give us our correct answer, which is 888. So it's not just if b minus c is less than 0, return c minus b. We would do if b minus c is less than 0, we would do we would pad on absolute for making it. We could use absolute value. You could, if you so desire to do that. But let's do it like this. So let's do, how do I pad on? So let's do return digit difference, not different, A, turn A. So how would I pad a 0 onto the end of A? Right? I want to add an extra number here. How would I do that? Times 10. And I'll show you guys how to do it in one line after this, if you still want to. A times 10, and then I want to, if b minus c is less than 0, I want to do plus c minus b. Otherwise, b minus c is greater than 0, so we return a times 10 plus b minus c. Okay, and that's your code. This is the code. Okay, and if you guys are curious, you can do it in one line. Do it like this. I shouldn't erase that.
Do you mind explaining the return part again?
Sure. So return. So there's two cases, Rachel. So A right now is storing. A right now has the answer for the first like parts of both inputs, right? But we have to now perform the subtraction for the last digits of both inputs and put it on the end of A, right? But there's two cases. Either the digits subtract, right? So we're doing like b minus c. B is the last digit of x, and c is the last digit of y. If b minus c is a negative, right? We can't add a negative number at the end of it. It has to be entirely positive, right? Yeah, it has to be two positive. It has to be a positive value that's returned. So, which means that if b minus c is negative, then we have to flip it. So we do c minus b, and then we pad that on to the end of the current answer, which is a. right? So A in this case is, like if I use this example again, we gave the computer 99 and 11. It returned us 88. We want to add on 9 minus 1, which is 8. So we do A, which is this portion is A. So A times 10 plus the difference between the last two digits, which in this case is B minus C, right? If this was like 991 and 119, we would do 88 once more, but we would do C minus B, 9 minus 1, which is 8. Okay? Does that make sense? Yep. Okie dokie. Is everyone good with this question? Everyone okay? Okay. Sounds good. Alrighty. I think someone said, what was the other question that was mentioned? 150 something? See how hard 134 is. Right, recursive function odd digits that returns the number of odd digits in an integer parameter. For example, a program uses odd digits as follows. Number 10 has one odd digit, namely 1. There's no odd digits. Has 3 odd digits only, namely 1, 9, and 3. Okay, this one's pretty easy. I'll show you guys why. So what does it return? What does it return? Int. It returns an int. So int, name of the function is odd digits. What is the parameter? Name it int. You could name it int y. Int y. Let's name it xy. Why not? I'm joking. No, that's not xy. Int y. What's the base case? What's the simplest case? If I give you a number, what was the simplest case? Yep. If y is less than or equal to 0, return 0. Bingo. So now, let's do it. Once more, we could do this multiple ways. But say, let's do it like this. Like having it like this. So int, let's not do it like that. So there's two cases, remember. So now we have the number. Say we gave, let's say we gave this number, and we gave the portion from 1 through 1968, and it returns that it has two positive integers. Yeah, we could do that. Okay. Sure, that works. Int s is equal to odd digits of y. How to make y smaller again, guys? Y10. No, mind. You wrote it in the chat. My fault. So in this scenario, this s would be 0. S would be 2, right? So now there's you got to think about it. Depending on the last digit. So if the last digit is odd, we add 1 to s and return that as the answer, right? Otherwise, if it was, say it was a 2, we need a count. Well, in this case, we don't really need a count. I'll show you why. Because right now, after this, go over any command and argument question and string them because they're both in the exam. Sure, we could. I think someone else said we could, after this, we could do, someone wanted this 2D array. We'll do that. And I think someone also mentioned characters and string things. So we'll do that. We'll do those, okay? String, and we'll go over a few command line arguments. Never use command line arguments, but sure, why not? For Josh's question, we don't really need to count. And I'll show you guys why. Because here, we're just assuming that this returns a number of positive integers, not positive, odd integers, right? So right now this returns 2, right? 1968, 2 odd integers returns 2. We want to add 1 or subtract 1 depending on whether the last digit is odd or even. So how would I do that in code? How do I check if the last digit is even? Anyone? Okay. So if, well, yeah, that works. If y mod 2 is 0, that means the last digit is even. So then what do I return? So that means this case it's 2, right? And remember, s right now is 2. If the last digit is even, then this adds 0, and we would just return s, right? Is everyone okay with that? Here we just return s. Otherwise, what's the case? The last digit is not even, it's odd. So we return s plus 1. Okay? Does anyone have any questions about this? Any questions at all? No questions, no questions.
Oh, just to clarify, so that means like if there are even numbers, that means there's 0 odd numbers, and then if there are odd numbers, then you count it.
Yeah, you basically count it for every time you see an odd number. You count it, yeah. So if say in this case, it could be done with a count, but you would need to use like some loop. Either you use a loop or you have to add an extra parameter, right? That keep track of the count. But in this case, you don't really need the count, right? Because say, for example, we have 10. Is 10 less than 0? No. 10 s is equal to odd digits, so 1. 1 just returns 1. In this case, it recursively keeps track of the count, if you want to think about it like that. I don't want to confuse you guys. Like you don't need, yeah, you could do it with a count, but it overcomplicates it. You could do it recursively without the count. And I think to answer Rachel's question, we basically check the last digit and add it to whatever we was given returned to us from the computer. If you want to do it with a count, I think you would need to use a loop. Recursively, this is how you would do it. Is everyone okay with this? Everyone good? Any questions? Any questions? Feel free to ask questions. I don't want to like rush it. It's basically, yeah, it's adding 1 and 0 to the count. Like if it's, yeah, it's kind of under the hood keeping a count. You want to think about it like that. You want to like specifically create a count variable for it. Any questions? Any questions? Any questions? I'm gonna take the silence as a no. So let's finish recursion. Let's do a 2D array problem real quick. Sum has 2 array parameters, first and second. The first is a 2-dimensional with 5 columns, second is 1-dimensional with the same number of columns. The entries of both arrays have type int. Additional parameters specify the row and column counts for first. For example, a program that uses the function follows. Okay. All right. Oops, almost said something in the chat. Will you go over any file questions? I will go after after this. We're just gonna do one program design question with like 2D arrays. Then afterwards, we're gonna go over string stuff. I want to say string stuff. Is it not on the exam? I'm not sure. I never. Char string. Yeah, we'll go over char string manipulation. Yeah. Like this is a good example, like right here. Example right here, right here. Like string functions, string stuff. Function signature we don't need. Program output's pretty easy. We're just gonna go over one program design question. It's not doesn't hurt. Right, so let's have the function. So the function, what does the function return? Does the function return anything? And yeah, we'll go over command line arguments as well. I never did command line arguments, but we'll go over them. So does this function return anything? Are you sure? Look in the line. Does it return anything? Is there anything with the line? It's not with anything, right? So it's void. Yep. So void, call sums, and it's going to take in 4 parameters. So the first parameter it takes in is the array. First array. So we could do, it's an array of integers. So that's int, let's name it x. Name it first, just keep it. And because it's a 2D array, we need to keep track of the first, right? I think is the first number. Sorry, let me just make sure this isn't. 2D array and function C++. Yeah, it's a second number. My bad, chat. It has to be a second number. It's printing though. Why void? It's not though when you call a function right here. The function is called right here. There's a short response question from program design. Oh, okay. Well, here it's because when you call the function, it's not like with anything, right? It's printing afterwards. So it's gonna print afterwards, like from the array. But when you call the function itself, it's not doing anything. Right? No worries. So it's void. So it's gonna be first, and we always got to keep the size of the 2D array. So it's gonna be 5. There's gonna be a second array, so we're gonna do int second. We don't, because it's a 1D array, we don't need the 5, we just need to keep the square brackets. And then we got 2 things. So we got int, let's say rows, and let's say R, and then C. Okay. So these are the parameters. And then what will we do now? Okay. So the idea is we need to loop through the array row by row, and we want to update. So let me just draw this out real quick. So we have the column, the table second, right? 2, 3, 4, 5. We want to update each column or each part in the second array with the sum of the corresponding columns from the first array. Right? So we would loop through. Right? This would be a 2D loop. So for int I is equal to 0, I is less than R, I plus plus. And then we could do for int j is equal to 0, j is less than c, j plus plus. Right? Right. So now what do? We have to update the corresponding column in the second array with the sum of the corresponding row and column in first. Does anyone have any ideas how we would do that? Anyone, any ideas? I'm going a bit fast. If we have time, we can go a bit into command line arguments and the other. stuff. Any ideas, anyone? So second J is equal to, well, not 0. We don't want it to be 0. We want to update it. But it's not going to be equal to 0. We're going to update it with whatever it's going to be here. So like if we're on row 1, here you go. It's not going to be first, second J is going to be plus equals first IJ. Yep. First IJ. Okay, so this is basically saying, so if we go through it, let's go through the example. So at row 0, we're here. So column 1 is 1. So column second, oh sorry, it's a 0. So second 0 is gonna be plus 9. And then second 1 is gonna be plus 9. Second 2 is gonna be plus 8. Second 3 is gonna be plus 1. Second 4 is gonna be plus 0. Once again, row 2. So second 0 is gonna be plus 2. Second 1 is gonna be plus 9. Second 2 is gonna be plus 8. Plus 1. Plus 0. And then this is gonna be end up being 12. It's going to be plus that, which is 12. 9 plus 9 plus 19. 24. 3, 0. Okay? And that's it. That's your code. Does anyone have any questions about this code? You're just updating in 12, 19, 24, 30. Yep. Looks good. Is everyone okay with this? Everyone good?
I'm still kind of confused about like updating from the first to the second array.
Updating from the first and second. So what are you confused about? Specifically.
Going from, why do you need the second array? I'm still kind of confused about that.
About this array?
Yeah.
So this array, the second array, is what's storing the sums of each column. So like for the first array, the sum of every element 0 in each row is gonna end up being in element 0 of the second array, right? And then the sum of each element of each column's 1 in the first array is gonna end up being the sum in second J. No, it's gonna be second J. Because J is keeping track of the columns. Remember, because if you think about it, first only has 3 rows. So 0, 1, 2, 3. Right? Second J, if it should be second I, then I only goes up to 3. We're gonna be missing out on these last 2. Right, Josh? You see that? Like, so call the R's only goes up 0, 1, 2. So I only goes up to 2. But we also need to fill out 3 and 4. That's why it has to be second J. It has to match. Right? And for Rachel, does that make sense? We're just adding, so we're going through each row and we're taking the value in a certain column and adding it to like this is like a row of just sums for each. That's why it matches 5, 5. Does that make sense? Okay, glad to see everyone's on the same page. So that's good. I think that should be enough for program design. We have So let's do not function signature. Command line arguments and string manipulation. So I've never, just like a bit of a warning, I've never done command line arguments. When I took 111, I never learned command line arguments, but let's see. Does anyone have a question in particular they want to go over? It could be command line arguments. It could also be string questions. So, or character manipulation. Anyone have anything in particular they want to go over? 2050. This one? I'm assuming it's this one. All right. Compiled to A out and executed with the command A out 1 2 3 4 5 6 4 5 6 7 8 9 1 3 5 7 9 9. I think there might be a typo here because we don't. He's missing the arg value array in the main. So let me just write that here. So this would be main. What is it? Int arg count. Int arg counts. Char. Arg value. Okay. All right. So we have a string of words 1 2 3 9 8 7 9 8 7 6 5 4 9 9 9 9 7 7 7 7 7. So first we have to do words 2 dot substring 2. So everyone knows what the string, what's it called, methods are, right? Substring, find, length. Everyone? String function. We're doing good? Okay. So let's start. So words 2 dot substring 2. So firstly, it goes to the word array. It goes to the element 2. So remember, it starts from 0, 1, 2. So it goes here. So 9, 9, 9, 9. Also, if anyone needs to leave early, feedback form. Thank you. Everyone's here. But yes, okay. Everyone here? So we go to word 2, which is 99999. And we want to print a substring. Right? And I remind me if I'm wrong, but substring, if it's one parameter, it starts from 2 and goes to the end, or does it start from 0 and go to 2? Position, part of a string. Okay, so but when it's only one parameter, so I'm assuming, so words 2 is going to take a substring of this, right? So I'm going to take a substring. Okay, so it's 2 to the end. So in this case, it's going to be 9999 9. It starts at position 2, so this is 0, 1, 2, and it goes to the end because it's only one parameter, so it only prints 99. Okay, everyone good with that? Okay, so then can you please tell again about like substring 2? Okay, so for substring 2, I'm assuming that if it's only one, so the idea of substring is that you give it a word, so like a string, right? And we're doing dot substring, you only want a part of that word. So you want part of the string given, right? So we're giving words 2, which is 0, 1, 2. This is the word we're using. We only want a part of the word. And the thing with dot substring is that the parameter given denotes where you start from, right? I think if there's 2 parameters, that's like the start and the end. But if there's only one parameter, that means we start at index 2, right? Because if you remember from class, a string is basically like an array of characters. So we start from index 2, which is in this case going to be a 9. And then we go, because it's only one parameter in the function, we go all the way to the right. So it's just going to return 99 all the way to the end of the string. Okay. If you put substring 0, it would return the entire string because it starts from position 0 and goes all the way to the end. Does that make sense? Okay. So now, part B. So for int I is equal to 1, I is less than or equal to 3, see out words I, see out end line. Okay. So we start at index 1. So we start at words 1. That's part B. We start at words 1. And we go at in words 1, we go to index 1. So this is 0, 1. And we print out that symbol. In this case, it's going to be 8. Okay. 8. And then we go to words 2. We go to index 2. So 0, 1, 2, which is a 9. So 8, 9. That's a 7, not a 9. Sorry. This is a 9. And then we go to words 3, which is this. Words 3 and index 3. So 0 on the same line. No, because it's the C out end line. See how there's a C out end line? Wait. Oh, wait, sorry. I'm sorry. There is. My fault. Didn't see that. It's weird the way he does this. He does semicolon. Yeah, there's a yeah, so that's gonna be 8, 9, then 0, 1, 2, 3, 7. Yep, thanks for calling that out. Semicolon here, so this is like a separate line. Right, so that's 8, 9, 7. Any questions? Pretty straightforward. Any questions? Let's out. Sorry, I'm just doing out slash a dot out. Yeah, just want to make sure. Okay. So next next part. So this is what I just searched up because like I get confused. Like I never learned this. So apparently, so we got a out execute with a command. When you look at command line arguments, a dot out, this is also counted as an argument. So right now we have 1, 2, 3, 4. Okay. I think I might have said to someone, I think it was Josh actually, that the out doesn't. Actually does. I had to ask a bunch of my friends at Twitter at the Learning Commons, and I had to like do some research on my own. Apparently, it does count. So this counts as one of the arguments. It does. Right. So now, when they're asking us to set words 3 as arg2, remember these are then stored. These are stored when you do a command line arguments. These are stored in the array right here. So these are stored here, and argc contains the number of arguments that we have. Right, so here it's going to be 1, 2, 3, 4. So argc is 4. I'm assuming. Let me just make sure that's correct. Hold on. Yep, argc is 4. Someone correct? Is that good? argc is 4? Okay, argc is 4. Okay. So now we want to set words 3 is equal to argv2. So remember, count it at 0. Executed file does count as the argument. Thank you for confirming that. So we got 0, 1, 2, 3. We have to set words 3 is equal to argv2. Yes, we start at index 0. You go less, I think we go less than count, so okay. So words 3 is now argv2. So argv2 is going to be this one, because in the array. So now words 3 is no longer 7, 7, 7, 7, yada yada yada. It is now 4, 5, 6, 7, 8, 9. That's a 4, by the way, in the beginning. 4, 5, 6, 7, 8, 9. Okay. So now the next line, we do cout words 3 dot find 9. Well, the find function, it returns the very first index that has the string given, right? So we go through the argv to words 3 character by character, and we find that the first 9 is at the very end. This is going to be 0, 1, 2, 3, 4, 5. So C returns 5. Okay, is everyone good with that? Any questions about it? Word dot find. And for argc, I believe wait, that was D, right? That was C. Oh shoot, sorry. C is cout words 3. I'm sorry. C, you have to now cout words 3. And since this line sets word 3 as arg2, so arg2 is this. So now cout words 3 is going to give this. So it's going to be 4, 5, 6, 7, 8, 9. And for part D, well, we have to do words.find. So the dot find function, it returns the very first index of the first time that you see this string, right? So the index of the first time you see it. So if you go through it line by line, like not line by line, character by character, words 3 is now this 4, 5, 6, 7, 8, 9. You have to return the index of the first instance of 9. So that would be the very last one, because that's the last time. That's the first time you see 9 in the string. So 0, 1, 2, 3, 4, 5. That's why this will return 5. Does that make sense? And once again, argc keeps track of the count of the arguments, how many arguments we have. 0, 1, 2, 3. No, sorry. Don't start counting from 0. 1, 2, 3, 4. 0 is just the index, so that would be 4. Right? Feedback form for anyone who's going to leave early. But yeah, is that everyone good with this right here? Is everyone okay with this? With this question? Yep. Can we go over string example? Do you have a string example? Like most of the like strings are gonna be like testing you on string functions like dot find, substring, stuff like that. Does anyone have any other question they want to go over in specifically?
I don't have a specific question, but I was wondering if we could do another pattern, but a bit more complex.
From nested loops?
Yeah.
Okay. Does anyone, before we do that, before we like switch over, does anyone want to go over anything here? Like any other character question or string question? I think someone wanted to do character manipulation. Let me find a character manipulation. And then we could do, yeah, string character manipulation. Let's do that. And then we'll do a nested for loop to finish it off. Okay, uppercase and lowercase. Well, before I do that, let me just I'm pretty sure he's shown you guys the ASCII table, right? This is basically what how you do character manipulations. And you learn more about this in like 240 when you learn about different ways of storing stuff in the computer. But the reason why in the computer, right, or like in code, you could like usually see like when you compare characters that you could do, like say you have a character, it's like A equals B. Like usually for strings, you have to like use the dot equals. There's like a separate method for strings. But for characters, you could use operators that use for numbers. Why is that? Because in the computer, characters are technically stored as numbers, right? So if you see here, let me find a bigger image. The hell? And you learn more about this in like 240. But like, okay, this is a good one. No. Sure. They're like, oh, that's actually not bad. Hex, not hexadecimal. Decimal, okay. So like you see here, the uppercase letters go from 65 up until 90, and then the lowercase letters go from 97 up until 122. So in general, I think, yeah, in the chat someone mentioned if you want to convert uppercase to lowercase, you add 32. Right? So you do the number plus 32, and then you convert it back to a character. If you want to go from lowercase to uppercase, you subtract 32. Right? So you do 97 minus 32 and convert that back to a character. So something like, let me just write it out here. So if you want to convert, kind of an example. I swear I saw one. Maybe it was earlier. No. There was one somewhere where it was. It had like character. This one? No. Where there would be the, yeah, I mean, okay, I could tell the people who upload their recording, so I'll try to upload it by today. But I hopefully it should be uploaded by today. And I'll show you guys where it's going to be uploaded near the end. I'm just trying to, but it should be uploaded by either today or like tomorrow. Don't worry about that. Okay, right here. There you go. That's a good question. So we'll do a few here. So char A is B, C out A. So this is going to C out the letter B. Char A is equal to B, while A is less than or equal to F. Right? See how we use not like operators with numbers on characters is because it's using the fact that ASCII counts as like characters count as numbers. So here it's going to be, I think, 97. No, not 97. This is actually while A is B. So B is currently 98. And you don't need to memorize the numbers. Actually, in this case, actually don't. Never mind. You don't need to memorize the numbers. Just remember, so as long as you remember, like, if anything, remember like the A is 97 and lowercase a is 65 and lowercase a is 97 and uppercase a is 65, then you should be good. So in here, A, like the character, the variable A is storing B, which is 98. So while A is less than or equal to F, so while B is less than or equal to F, or 98 is less than or equal to, and in this case, it's going to be 102. 102. C out A minus A. So in this case, a character minus a character is going to give A minus A. So B minus A is going to give us 1. And then B is increased. So B goes to C. Right? So it's either going to give us, it's not going to give A minus, yeah, it's going to be 1. Then it's gonna increase B. It's gonna be 99, which is technically C. And then C minus A is just 2. C is increased to D, so that's 100, which is D. Then 3, then 4, then 5. No. 98, 99, 100, 101, 102. Boom, yes, so this would be 1, 2, 3, 4, 5. Okay. But in general, if you want to like, for character manipulations, if you want to go from uppercase to lowercase, you always add 32. Can you explain what again? The numbering, the numbers here, or from uppercase to lowercase? Okay. So, like I said, in code, characters, even though they're just characters, they also technically count as numbers because of the ASCII table. Because in the computer, characters are stored as, like, there's different ways they're stored. Ignore the hex, oct, and those stuff. That's later on. But here, they're numbers. So in this case, character A is B, but B is technically 98. And A is 97. Lowercase a. So lowercase a, B is 98. And here, while B, well, in this case, A, is a variable. Don't get it confused. He does this to confuse you. This is talking about the letter B. So while the letter B is less than or equal to less than or equal to the letter F, we see out A, or the current letter that A is storing, minus, and this is important, the character A. Okay. A minus A. So this would basically do is take the character we're currently on, so this case is B, and subtract A. And you might be thinking, how do you subtract characters from characters? Well, it is possible because characters are technically numbers. So this would do 98 minus 97. And if I'm totally wrong, please correct me someone. It's been a long time since I did these. But this would, in my opinion, print out B minus A, which is 1. And then it increases A by 1. And by adding 1, it basically turns A from 98 to 99, which is C. So basically, the add 1 goes to the next letter. Next letter. Right? And it keeps updating. So it's 98, 99, 100, 101, 102. And the difference, it keeps increasing by 1 until it hits 104, which is not 104, 103, which you see here is after F. So that's G. So once the letter is G, it's no longer less than or equal to F. For the file, so we have to learn the index of the number. You don't have to necessarily learn the index of each number, like specifically, as long as you remember that, if anything, remember A starts from 65, uppercase A, and lowercase a starts from 97. You should be good because you can just count up from there. But yeah, that's only if you get something like this. But in this case, you just remember, just try to like memorize that lowercase a is 97, uppercase a is 65, and plus I doubt you're gonna get something like this. Is probably, if anything, with just like worth like 2 points on the exam, so you can, yeah, you'll be fine. For the file question, once again, I never learned file stuff when I took C++111. My guess is this is probably how it's gonna look like on the exam. Like, you're gonna have something like this in one of the questions, and then they might ask something regarding the the argc and argv, like this, like argv, C out argv1, or something like that, or like what we did in the earlier question with something like this, like command line arguments. So professor said the file one would be a complete program. Oh, great question. I don't really know. I don't have the questions to the exam, so I don't know what's going to be on the exam, unless the professor told you guys what's going to be on the exam. So I'm just as lost as y'all are when it comes to files. But I would assume that because he hasn't given, unless he said differently in class. No, I had a different professor. I didn't have Akinlar for 111. I took Chin for 111, and she does like file IO input at the very end. But it is input. It is important. Like it's useful to know how to take in input from files. Like you learn later on programming. Like you can't store everything in the code, so it's useful to have file input techniques. But yeah, when it comes to like file input, I'm not really sure. My guess is that something like this is gonna be, unless you're like I said, unless your professor said something different, I don't really know how the file ones will look like. Sorry, guys. Was everyone good with the character stuff? Everyone okay with this? For the file, I think it is a complete program design. Program design. Is there a question in particular you want to go over before? File. Is there a file question we could do quickly? I think someone also wanted a nested for loop, but if a file one happens,
Yeah, we could do file. I prefer file actually.
Okay. Does anyone have a file question in particular? 'Cause I don't know what he has here. Okay, right here. Write blocks of code to perform the functions using the following main program. Your block, yada yada yada. Okay, so int a is 1, 2, 3, if stream f, string s is hello, f.open test file.txt. Test whether a number has 3 digits here, yes. So I don't think we need to go over this. The is 3 digit, that's just a for loop. You just loop through, or you just use a while loop. So while a is greater than 0, you can have a count is equal to 0. If a is not 0, count plus plus, and you return count. If count is equal to 3, you return true, otherwise you return false. Here's a good count words. Number words. EOF is true. I have no idea how to do open test file. First word. So do you guys know how to read the file? Like, you know the code for that? Let me see. One second. Let me check. Let me search it up. C++ file reading. If stream reads files. Read from a file. So while get line string my text. So it's something like this. One sec. Like this. Is something like this. Just search it up. String my text, read from text file. I have stream my read file dot file name dot txt. Okay, so we could do it like this. Let's lower the size of this. Let's try it out. So the function would be count words. What's EOF? What the what? What's EOF? Is open? No. End of file. Oh, okay. Okay, so this would be okay. So this is gonna be doubles a string here. Hello. Don't double it. Count words. Number of words. So it returns an int, in my opinion. I'm assuming. You guys agree? Number of words. So int. Did he teach you how to use split? string.split method? Or no? I'm assuming no. Int count words as a parameter, it will take a if stream f. So, oh, okay, that's nice. Name of input file is hard coded into the program. Fstream fin.open. Okay, f.open. If then okay, that's okay. Let's check if it open. While is not end of line. Format to read file. Thank you, Tassine. Okay, let's use that here then. So it's gonna take in an IF stream as a input. Right, so it's gonna take an F as an input, IF stream. And then while it's not at while it is not end of line. In this case, that's gonna be so while not f dot end of line. We're gonna have a count. We're gonna count the number of files. So int count is 0. Count plus plus. Okay, so this is a number of words. So I'm assuming it's a file of just words. So then either one of the questions you ask him, like, is the file just words or is it like sentences? And we're assuming it's just a file of just words, like different word on each line. So we're just gonna do this. So if int count word, you have IF stream, let's say f, right? Count is 0. While it's not the end of the line, you increase the count by 1. In the end, we return count. Okay. And I don't think we need to close it here. We could close it, yeah. 156. Let's do that one. And then we'll have to call it a day because the next Zoom is gonna be soon, so I might have to add out. 156. Was everyone okay with this one? I'm like, just like you guys are confused, I'm just as confused. I've never use this file reader. But is everyone okay with this one? Oh, before you guys leave, no. Sorry, you left. No, wrong thing. Damn it. Hold on, hold on. There you go. Oops. All right. Is everyone good with this? The file reading? I think it's the same format. So it's just, and here you're gonna have a count. So while the file is not at the end of the line, you increase the count, and at the very end, you just return the count. You're just keeping track of the count of the words. Everyone okay with that? We can do one more. 156. 155, 156. Program to carry out the test. Reads all numbers. Okay. It asks the user to enter 25 integers and it reads the numbers that the user gives. It calculates the average of the entered numbers. It reports all entered numbers that are greater than the average by printing them to a file called output6 text. Okay. So for this, we might have to do an array. Let me do it down here. Okay, so let's do that. So let's do hashtag include. Let's do this quickly before the next comes in. IOStream using namespace standard. I think you have to include one more thing. So hashtag include. What do I gotta include? I use a file thingy. What do I have to include? Sorry. C++ files. Fstream. There you go. Fstream. Fstream. Okay, so int main. Does anyone here know how to output things to files? File printing. How do I output with files? Closing a file, text files. Oh, you gotta do, is it the my file? Hashtag include a stream. I think it's like this. My file, okay. So we would do, so we're gonna have to declare an array of integers. So let's say int array of size 25. These are gonna keep the integers. Okay. Array 5. And we're gonna have to create a total array. Int total equals 0. So we're gonna do this. So for int I is equal to 0, I is less than 25, I plus plus. We wanna see out, enter an integer. This is the wrong one. 156. Yeah, this is one. Yeah, this is taking the average. This is the wrong one. 156. Okay, never mind. Average. Okay. We're not doing this one. We're doing 156. It has the average. Okay. Enter an integer. Right. And then we see in, we want to see in the integer in the corresponding file name, string.open. Looks goody. Oh, I don't want to add. Oh, file name. Oh, stream, not open. There you go. Okay. Thank you, Rachel. Okay. So cin array I, and then, so now we have that. So that's, we have an integer. Oh, we want to do total as well. So we want to do total plus equals array I, right? So now let's calculate the average. So int average, double average is equal to total divided by 25, 25.0. The reason why I'm dividing by 25.0 is just to make sure, because total is an integer. So I just want to make sure that the average is an integer, right? It is a double. No, I'm sorry. The average is a double, because you could have averages that are point something. Like 2 plus 3 divided by 2 is 2.5, but it would give 2. So we want to make sure it's a double. So we would do double average equals total divided by 25.0 just to be safe. Okay, and I'm rushing. I'm sorry if I am rushing a bit. Next review session is going to come in like 7 minutes, but let's continue. So now let's do what Rachel sends in the chat. We're going to do string file name is equal to output 6.txt. OF stream, and then stream.open file name. Okay. So now we have to loop through, the idea is we have to loop through the array of integers, and those integers that are greater than the average, we print them to the file. So from the brief 2 minutes that I spent searching this up, file name inside to open it. So would it be something like my file? Let me show you guys. So we basically like loop through. So for int I is equal to 0, I is less than 25, I plus plus. And 0. We would do if array I is greater than average. Then what I'm thinking we do is we do, what's the file name? No, it would be file name stream my file. Would it be stream like this? This is what I'm assuming. Is this what the professor taught you guys in the lecture? Something like this, like you output it to the file. So stream. Anyone? Grasping at straws. Is it? Okay. So we do stream. No. 2 arrows, an array I. All right, so this is only printing it if the array I. Oh, wait, sorry. Is that? Cout. Is it like I'm thinking for the backwards, that's for cin. So I think that's like taking in file input. Like that's you use cin, like right here. That's when you use it. Cout is when you're like printing. So I'm assuming it's like this as well for printing. Someone correct check me. Yeah. Who's that? Whoa. Oh, it's Roi. But yeah, so that's is it cout? So you do so is it stream this array I or is it just like cout? Because cout would just print it to the console. Okay. So stream this thing, array I. Okay. I think that's it for the code then. So you take in the inputs, read them one by one, calculate their average, and then you have a file. You open the file, and then you go through the array. Okay, not cout, but once you go through array, go through the array. I can't speak. One by one, you check if the current element is. Oh, because in the array, in the question it says, where is it? It reports all entered numbers that are greater. I haven't later. Greater than the average. You see that? That's why it's array I greater than average. The number has to be greater than the average. Okay, and I think that's yeah. So we went over how to output to files. I think we went over how to input to files as well. So sounds good. Is everyone good? Any other questions? I'm gonna take a speed nap for the next one. Everyone okay? Also, so that you guys know where it's gonna be, QC Learning Commons. The thingamajiggy stream, yeah, it writes it into the file. So then it puts it in the file, and then once you close the file, it should update the file automatically. So if you go to, also before anyone leaves, feedback form. If you go to Learning Commons website, you go to resources, computer science resources, you should see under CS111, the final recording will be here. Okay, for anyone who's interested. So I'll let them know. They'll get the recording soon and you will get it eventually. Okay, so I'm gonna stop sharing. Went a bit over. The next one's gonna start in like a minute. All right. I wish you all the best of luck in studying. Those of you who stuck through the rest of the way with me, appreciate it. I appreciate it. And yeah. Good luck.
Sorry, can we join the other review, or that's only for the other class, right?
You guys
Um,
pay for it if you want. It's not so exclusively for them. So it's a 111 review.